In this video, I'm going to show you how to analyse the data from an experiment to calculate the molar volume of a gas. The experiment we will be looking at is the reaction between magnesium and hydrochloric acid. One of the products of this reaction is hydrogen gas. The data that we will be using is shown here. This video links to another video on the channel, and the link to this is given in the description. To analyse the data, we start by opening Microsoft Excel, which you can see here. And I'm going to start by typing the titles into the spreadsheet. So I've got mass of magnesium in grams. So if you notice here a volume of hydrogen in cubic centimetres, the size of the cell is actually wider than the size of the column. So the way to fix that is to hover the cursor over the division between columns B and C, and if you double click, then it automatically becomes the right size. I need to make this 3 a superscript. So the way to do that is to highlight the cell like I've done here, highlight the 3, right click, move down to Format Cells, and click Superscript. And you can see that that 3 is now a superscript as it should be. I'm now going to enter the numbers from the data table into the spreadsheet. Now that all of the data has been entered, we can look at formatting the data that we have. The first thing we need to do is to center the columns. So if you highlight the columns like I've done there, then go up to center, click it, and it centers the numbers. If you look at the data that we've been given in the original table, you'll see that the masses of the magnesium have all been given to 3 decimal places, and that reflects the level of accuracy of the balance that's been used. So you'll notice that some of the numbers, for example, on row 30, which I've highlighted here, because the final number is a 0, Excel hasn't shown it. But just so that we can be consistent, it's good that these are all explicitly shown to 3 decimal places. So the way I'm going to do that is I'm going to highlight the numbers like I've done, and then I'm going to go to where it says number at the top here. And I'm just going to change this so it says 3 decimal places. You could also have done that by right-clicking, going to Format Cells, and changing the number of decimal places. Similarly, the hydrogen volumes in the original data table have all been given to 1 decimal place. So in row 2 here, the original data would have been 24.0, but Excel has automatically not shown the 0.0. So just to be consistent, I'm going to highlight those numbers, I'm going to right click, I'm going to go down to where it says Format Cells, and I'm going to change that so that they're all shown to 1 decimal place. And now you can see, even although it's 24, Excel knows to put the 0.0 afterwards. It's often nice to make the titles bold so that they're easily identifiable. So I'm just going to make them bold like that. And I'm also going to make them a bit grayer, just so that it's obvious that they're titles. So I'm just going to add a grey background. So the way I'm going to do that is just by highlighting them, going up to this little paint bucket here, and I'm going to choose a nice pale grey colour, like that. And now I've completed taking the data from the sheet you saw and entering it into this spreadsheet. So this is original data. It would have been from 2 classes, and it's real data that the students obtained from experiments. So now I'm going to use this data and I'm going to plot a graph. So whenever I've got 2 sets of numbers from an experiment like this, the most common graph you would use is called a XY scatter. So I'm just going to highlight the 2 columns and I'm going to click Insert, and I'm going to go to Charts, and I'm going to choose this option at the top left, which says Scatter, and I'm just going to click it. And automatically it gives me a chart like this. And you can see that we've got a fairly nice trend. It looks quite a nice straight line. It is real experimental data. Hence, we've got 1, 2, 3, 4 anomalous points, but that's completely expected from experimental data. So I'm just going to tidy this chart up a bit. So I'm just going to start by removing this title. So that's just automatically generated. And I'm going to select the chart just by clicking on it. And now, if I just go up to the top here, you'll see that I've got chart tools. Okay, and I'm just going to click design. So I'm going to alter the design of the chart. So I'm just going to go to where it says quick layout on the left. I'm going to click it. And you can see that it's given me 11 different options. And if you hover the mouse over each option, you can choose the one that's most appropriate for what we want to do. Okay, so some of these are completely inappropriate. So for example, this one here, what it's trying to do is plot the data and next to each point put the corresponding values. But you can see that we have so many values that they all go on top of one another. So that's not good enough here. Okay, so I quite like this chart that we've got here. It's nice and simple. We've got a grid in the background, which looks quite nice. And we've got 2 axes titles that we can edit. So I'm just going to click that option. Right, well, we don't need this data label, so we can just highlight that and delete it. So the X axes, so if you look at the numbers there, those are the numbers from the initial column. Okay, and that's what we have control over. So in Excel, the thing that you have control over, the thing that you decide, is what we call the independent variable. That always goes in the first column of an Excel file, as I've done here, and automatically Excel puts it on the horizontal axis. So I'm just going to highlight the axis title and I'm going to type mass of magnesium. I'm going to include the units. Equally, for the vertical title, I'm going to add volume of hydrogen. And that has units of cubic centimeters. Again, that 3 we need to fix. So if you highlight it as we did before, right click. This time we move down to where it says font. Click font. And we want it to be a superscript. So normally when you need to do something funny like that, the first thing you would do is highlight it, right click, and then look for something that looks appropriate. And so you can see we have the graph that we wanted. So the thing that we have control over, the independent variable, is on the horizontal axis. That's the mass of magnesium. And the thing that we are measuring, that's the dependent variable. The thing that we don't have control over, that goes on the vertical axis. Okay, and as I indicated, in Excel, the thing that you're controlling, so the independent variable, normally goes in the first column, and the dependent variable, the thing that you measure, goes in the second column. And if you do that, Excel recognizes what you want to do, and it means that the axes are the right way around, as they are here. Okay, and so this is a scattered diagram that we wanted. So what I want to do is I want to take this scatter graph and I want to actually put it in its own sheet. So at the moment, it's just a small little section inside this spreadsheet. So what I'm going to do is I'm going to just click it and then I'm going to right click it. And if you scroll down, there is an option that says Move Chart. So if you click Move Chart, you can see I've got two options. So at the moment, it's an object in sheet 1, but I want it to have its own sheet. So we're going to have a new sheet and we're just going to call it chart 1. So if I do that, it automatically places the graph into its own sheet. And you can see I've got two tabs at the bottom here. I've got my original data, which is called sheet 1, and I've got the corresponding graph, which is in this tab called chart 1. I'm going to show you. What you do is you select one of the points, doesn't matter which one, and you right click it. And you can see you have a set of options, and one of them says Add Trend Line. I'm just going to click that. Okay, so we've got a few options here. So there are a few different types of trend line. So at GCSE level, almost all of the lines you will be looking at will be straight lines. And so I've selected linear. Doesn't necessarily have to go through the origin. Okay, but the points we have clearly lie on a straight line. So I've selected linear here. And here we have the graph we've just made in Microsoft Excel. So I've obviously printed it out here, but you could just do what I'm going to show you using the image on your screen. So we know that 1 mole of magnesium has a mass of 24 grams, and you can find that by looking at the periodic table. Now, using proportions, that therefore means that if we have 0.024 grams of magnesium, so that's 1,000th, then that would correspond to 0.001 moles of magnesium. Again, just divided by 1,000. Okay. So if we look at our graph, so we're looking for 0.024 grams. Okay, so I've got 0.02 here, 0.04 here. I've got 5 boxes in between them. So that means each box is 0.004. So 0.024 grams of magnesium would be there. And so all I'm going to do is I'm going to draw a dotted line up to our straight line of best fit. And then I'm going to go horizontally across to the vertical axes. Like that. Okay, so you can see that I've got 20 cubic centimeters and I've got 40 cubic centimeters. And in between them, I have 5 boxes. So that means that each box is 4 cubic centimeters. So just estimating, so I can see that I'm in the second box. I'm pretty near the top. I'm going to say that's around about 27 cubic centimeters. So if we consider the balanced equation for this reaction, we've got magnesium, which is a solid, reacting with HCl, so that's hydrochloric acid, and we're making 2 products. So magnesium chloride, that's just in solution, and we've also got hydrogen, which is the gas that we've measured in the experiment. So you can see that if I have 1 mole of magnesium, it would give us 1 mole of hydrogen, H2. So that also means that if I have 0.001 moles of magnesium, it would give me 0.001 moles of H2. Now we know from the calculation that we did back here that 0.001 moles of magnesium is equal to 0.024 grams. Okay, so that was just the calculation that we did there. Now from the graph, okay, we know that 0.024 grams gives off 27 cubic centimeters. So we know that 0.001 moles of hydrogen gives 27 cubic centimeters. So our job is to work out the volume of 1 mole of hydrogen. And that is a simple proportion calculation. So we know that 0.001 moles is equal to 27 cubic centimeters, and therefore 1 mole, so all we've done is multiplied by 1000, and if we do the same on the right hand side, we get 27,000 cubic centimeters. Now normally in this type of calculation you need to read the question carefully because they normally specify the type of units that they want, but there's no need to change the units unless they've asked. Okay, so in this case the units I've got are cubic centimeters. If we needed to change it to cubic decimeters, so remember a cubic decimeter is the same as a litre. Okay, so that's quite a big thing. Okay, so compared to a cubic centimeter, a litre is a big volume. So that means that we would have fewer of them. And as I'm sure you know, the factor is 1000. Okay, so there are 1000 cubic centimeters in a litre. So 27 decimeters.